Okay, so in this example, I will be solving a word problem. So the word problem is a 12-pound object stretches a spring 2 foot by itself, where there is no damping force or external forces acting on the system. The spring is initially displaced 6 inches or half a foot upward from equilibrium, and we are given the initial velocity of 1 second, and we will have to find the displacement of this equation. So first, we're going to begin by setting up the initial value problem. So we were given that there is no damping force. Oh, there is no damping force, and there is no external forces acting on the system. So we're left with mu double prime and then ku plus ku is equal to 0. So to find m, that is the mass, and we get that from this equation. Mass is equal to weight times gravity, or 12 divided by 32, and that is equal to 3/8. And then our k value, the length it was displaced by was equal to 0.5. And to get the k value, it is our mass divided by length. So that becomes mass divided by length, and that is equal to 3/8 divided by 0.5. So, I think I might have that one wrong. Oh, wait. Our length is 2, actually. I apologize. And our mass is 12. So 12 divided by 2, and that's equal to 6. So we set it up over here. We get 3/8 u double prime plus 6u is equal to 0. So we take the complementary solution first. So we get 3/8 r squared plus 6r is equal to, oh, no, I'm sorry, not 6r. So solve for r, we get r squared is equal to negative 6 times 8 over 3. That's negative 2 times 8, 16. So r squared is equal to negative 16. Take the square root of that, we get r is equal to 4i. 4i plus or minus. So that's just I. But now we have no alpha is equal to 0, and our beta is 4. So plugging into our equation for complementary solutions, we get y is equal to c1 e to the 0 t cos of 4t plus c2 e to the 0t sine 4t. These are just 1, they go away. So I am going to erase the top, well, not yet. I'm going to keep on setting up this equation. So our displacement, our initial displacement, so our initial, so our u0 is equal to 1/2. Is a negative or positive. So upward is negative and downward is positive. So we get our u, well, this is actually not a y, it's a u, ut. Our ut is equal to 0. Our u0 is equal to 2. No, 1/2. 1/2. And initial velocity, so our derivative of u, of 0 is equal to 1. So, I'm going to erase the board. He said that upward was negative, so there we go. Okay, so in order to get u prime, we have to divide our u equation. So I'm going to derive it. So we're going to get u prime of t, derivative of cos 4t. That just becomes negative c1 negative 4c1 sine of 4t. And the derivative of sine is just cosine. So we get plus 4c2 sine 4t. Okay, so in order to solve for all these, we got to plug in our formulas. So for this one, we get 1 is equal to negative 4c1 sine 4, 0 plus 4c2 sine. Oh, and this one just became cos. I'm sorry. Cos 4, 0. So this sine to 0 is just 0. We get 1 is equal to 4c2. This just becomes 1. So you get 1 equal to 4c2. Solve for c2, divided by 4. So c2 is equal to 1 over 4. Now back to this equation, the original one. Our ut is equal to negative 1/2. So negative 1/2 is equal to c1 cos 4, 0 plus c2, or 1/4 sine 4, 0. This cancels out because sine to the 0 is 0. So you're left with negative 1/2 is equal to 1. Cos of the 0 is just 1, so c1. So plug all these constants back into the original equation. We will get the general form for the displacement of the word problem we just worked on. So ut is equal to negative 1/2 cos 4t plus 1/4 sine 4t. And that is our solution.